This video is part of the Commercial Building Electrical Design series. It's in the division of the Power Distribution Design, and we are looking at basic materials. So today we want to look at conduit. So just showing where we are on the progression, we've gone over delivery systems. We've been talking about materials, and we've already talked about wire, cables, and cords. So again, today we are going to talk about conduit. So while it is permissible in many applications to distribute power in a building using cables and cords, the more common way to distribute power in a commercial building is by using different types of conduit or tubing. In these applications, the conduit system, along with appropriate junction boxes, are fully installed first, and then the conductors are pulled in these conduits from the appropriate distribution panel to the loads that they are serving. While this is generally a more expensive installation, it is also a more flexible and robust installation in that it will generally accommodate changes in future upgrades more readily. In this section, we'll briefly introduce the most common types of conduit utilized on most common commercial building applications. So the first type of conduit or tubing is called electrical non-metallic tubing, or referred to as ENT. So this is a light, flexible, and strong non-metallic raceway system for use in walls, floors, and non-plenum ceilings. The use of this type of conduit is governed in NEC Article 362. Because of its blue color, as seen in the picture over here on the side, many electricians refer to this type of conduit as Smurf tube. So that's the slang that's commonly used in the field. So you might hear that term pop up, and if you hear that, they're usually talking about ENT. So this is generally not a commonly used conduit due to its lack of endurance and protection offered to the conductors compared to metallic forms of conduit. This can be a good solution for special cases where installation space is tight, such that the use of metallic conduit might be unruly or hard to install. But many electrical engineers forbid the use of this type of conduit on their electrical building system projects unless express written permission is granted. Flexible metallic conduit, or abbreviated FMC, is a flexible corrugated metallic conduit, as shown in the picture over here to the right, that comes in several different forms. The use of this type of conduit is governed by NEC Article 348. It can be constructed of either high-grade galvanized steel or an aluminum alloy strip of uniform gauge. FMC can also be specified as either full or heavy wall for more rugged environments that require more mechanical protection, or in a thin wall that is lighter and a bit more flexible. FMC is typically not specified or allowed to be used as the main conduit for branch circuit runs, but it is usually used to make final connections to equipment and devices. It is often used to make final connections to equipment or light fixtures from a local junction box. In these types of applications, the flex is typically referred to as a flex whip and is limited in length to 6 feet. Many fixture manufacturers will pre-install these whips upon request. Liquid tight flexible metallic conduit, or LFMC, is a flexible corrugated metallic conduit with a liquid tight PVC outer jacket, as shown in the image over here. The use of this type of conduit is governed by Article 350 of the National Electrical Code. Other than the outer PVC jacket, it is basically the same as flexible metallic conduit, which we talked about in the previous slide. LFMC can also be specified as either full heavy wall or more rugged environments that require more mechanical protection, or a thin wall that's lighter and more flexible. LFMC is typically not specified or allowed to be used as the main conduit or branch circuit runs, but again, it is usually used to make final connections to equipment and devices that are outdoors. It is often used to make final connections to equipment from local junction box. Electrical metallic tubing, or EMT as you might hear it referred to, is a rigid, unthreaded, thin wall raceway manufactured in various cross sections that is constructed of either steel or aluminum, as shown in the image here to the right. The use of this type of conduit is governed by NEC Article 358. EMT can be used as an equipment ground when used with the proper fittings and installed correctly. However, Most designers and engineers require a separate grounding conductor be used in lieu of using the conduit as a ground. This is probably the most commonly used conduit in electrical building system installations because it is the lightest and cheapest form of rigid metallic type conduit available. The use of EMT is many times limited to a maximum of either 1.5 inches or 2.5 inches by many engineers in their specifications. This is because at the larger sizes, other types of conduit provide much more physical protection for critical feeder type circuits. Most designers also forbid the use of EMT in exterior, underground, and in concrete installations. EMT has several types of fittings that can be used to connect the conduit to either another piece of conduit, which is called a coupling, or to a junction box, which is called a connector. The cheapest form is a set screw fitting. These are only for indoor use, and this is what they look like, and you'll notice them because they will have a prominent set screw. For outdoor use, compression fittings are typically specified, and so this is what a compression fitting looks like, and as you screw it down, the threaded portions are tapered so that the more you screw, the tighter it gets, and it will create a liquid tight connection. And finally, there's also an indent fitting that you might see that rely on using a crimp tool to compress the fitting onto the conduit, and this is what they look like. So you come with your crimp tool and you squeeze it on there twice, and it'll indent it to keep it on the conduit. These aren't weather tight, and their use is in decline because the connection is not always the best. Intermediate metallic conduit, or IMC, you might hear it referred to, is a threaded thin wall steel conduit that typically has a zinc-based coating, which causes it to have a shiny finish as seen in the picture here. The use of this type of conduit is governed by Article 342 of the NEC. IMC is typically lighter and cheaper than rigid metallic conduit, which we'll talk about next, but many feel it is a bit more difficult to work with as it many times is more stiff or brittle than RMC. For this reason, many contractors will opt for the slightly more expensive galvanized rigid metallic conduit in lieu of IMC, feeling that the difference in cost is made up for in the amount of labor needed for installation because it is brittle when you try to thread it. IMC can use all the same fittings as RMC, and it is allowed to be used in all the same locations as RMC. IMC does typically have a slightly larger inside diameter than RMC, but for all practical purposes, they are viewed as equal in terms of application. Like RMC, IMC is typically used primarily for larger feeders and underground applications. It is also widely used in hazardous location applications. IMC conduit is available in sizes ranging from 1/2 inch up to 6 inch, but in most commercial applications, 4 inch is the largest that will typically be used. And again, in the field, you can usually visually distinguish this from galvanized rigid because of its shiny finish, and this is due to the zinc-based coating. Rigid metallic conduit, or RMC, is a threaded heavy wall steel or aluminum conduit as shown in the image over here. The use of this type of conduit is governed by NEC Article 344. RMC can be made of either steel or aluminum and can have a number of different internal and external coatings applied depending on the application. The most common form of RMC is hot-dipped galvanized steel, or RMC, which is often abbreviated as GRC. As mentioned in the IMC section above, GRC is typically slightly more expensive compared to IMC, but is generally thought to be easier to work with in general applications. So like IMC, RMC is typically used primarily for larger feeders and underground applications. It is also widely used in hazardous location applications. RMC conduit is available in sizes from 1/2 inch up to 6 inch, but in most commercial applications, 4 inch is the largest that's typically specified or used. RMC does provide the maximum amount of protection available for conductors. Rigid non-metallic conduit, or RNC, is the next conduit we're going to look at, and probably the most commonly used is the polyvinyl chloride, or PVC conduit, as shown here. And it is the most commonly used in commercial applications for sure. So the use of this type of conduit and other RNC is governed by NEC Article 352. In general, PVC conduit is used in commercial construction as either Schedule 40, which is heavy wall, or Schedule 80, extra heavy wall, with Schedule 40 being the most common on the electrical installations. You'll see the Schedule 80 used more on plumbing and sometimes on primary when the utility company wants to run their wires in conduit. These types of conduit do not offer near the protection as metal conduit, so their uses are generally limited to underground applications in most commercial building applications. When used for incoming underground electrical service applications, they are many times encased in concrete to supply additional protection for the service conductors. PVC is also generally used for grounding applications as they will not experience the inductance issue generally seen with grounding conductors, especially with lightning protection applications. PVC conduit is available in sizes ranging from 1/2 inch to 6 inch, but in most commercial applications, as with the others, 4 inches the largest we typically see used. So just to go back to this statement here with the inductance, if on a lightning protection system for sure, when you do the down conductors, we almost never use metallic conduit because it can create an inductive effect when the lightning travels down the conductor inside another metallic tubing encasement. So we use PVC for that to reduce that effect. So that's the basic forms of conduit that you're likely to see on a construction site. And here there's kind of a comparison, all of them side by side, starting with your flexible metallic conduit, your liquid type flexible metallic conduit. This is your PVC, which is your rigid metallic conduit. And then your EMT, and this looks like IMC. It could be galvanized rigid. It's hard to tell from this picture, but it does look kind of shiny, so it makes me think it is the IMC. So the best way to tell between EMT and your IMC or RMC is that the rigid or intermediate or rigid metallic conduit will be threaded. EMT will not be threaded. So this is a pretty good comparison of what they all look like compared to each other.